Hello all. Last time we had seen what is meant by semiconductor. What is meant by p-type semiconductor? What is meant by n-type semiconductor? How these p-type and n-type semiconductors are formed. We had all seen in detail in the last class. Today we will be talking about what is meant by p-n junction. That means joining of p-type semiconductor and n-type semiconductor. We'll be learning about what is diffusion of carriers, depletion region, electric field, so on and so forth. You can see the figure on the left side. The p-type side, it contains excess of the positive charge carriers called holes, which are indicated by the blue dots. Alongside are seen the fixed negative acceptor ions, which are indicated by the grey dots. We already know that the p-type semiconductor is formed because of the trivalent impurity. Likewise, on the right of the first figure, the n-type contains excess of the negative charge carriers, which are called as the free electrons, indicated by the red dots. Alongside are seen the positive donor ions, which are indicated by the grey dots. Again, we have seen in the last class how the n-type semiconductors are formed because of the addition of the pentavalent impurity. Now, in the second figure, when p and n type semiconductors are joined, what will happen? The electrons which are on the n side, they cross into the p side, and holes from the p side cross into the n side. This is called as diffusion. That means holes diffuse towards the n-type and electrons diffuse towards the p-type. Why? What is meant by concentration gradient? The electrons are concentrated on the n side and the holes are concentrated more on the p side. Therefore, they naturally diffuse across the boundary, and this natural diffusion across the boundary is because of the concentration gradient. And when we say concentration gradient, that means we are talking of concentration of electronics on the n side and holes on the p side. Let us move further. Let us talk of depletion region in detail. When p and n layers are joined, the atoms in the n layer near the junction donate their fifth electron to the nearest atoms in the p layer. Now, during this exchange of charges, atoms in the n layer lose one electron. Why? We've already seen there is excess of one electron because of the pentavalent impurity added. So, the fifth electron goes to the p layer. Likewise, atoms in the p layer, they accept electron from the n layer because there is one hole. So, they become negative ions. In the n-type layer, due to the exchange of the charges, atoms in the n layer, they lose one electron and become positive ion. And in the p layer, since they accept the electron from the n layer, they become negative ions. Thus, opposite types of charges are produced across the junction as shown. This is called as a recombination. That means when the electrons go to the p side, they are accepted by the p occupied by the hole, and this process is called as recombination. Now what happens? After recombination, positive and negative ions remain near the junction. This leaves the fixed positive donor ions on the inside because it has lost one electron. It has become a donor. So since it has become a donor, what is going to happen? You have a one positive charge there. Likewise, and hence negative acceptor ions are there on the p side. Why? Because they have accepted the electron. So this is the effect of recombination. The positive and the negative ions remain near the junction. Further, these ions form an electric field because now they are immobile, they are not moving. Since they are not moving, they are stable there, they automatically form an electric field and it stops the further movement of the electrons and holes across the junction. This area where it forms an electric field is called as the barrier creation. What is barrier? You know what is the meaning of barrier? Barrier means not allowing. Therefore, this electric field stops the further motion of the electrons and holes. What is meant by depletion region? The area around the boundary becomes completely depleted of the free charge carriers. Which are the free charge carriers? Electrons and holes. So, what is left in that region? Only fixed charge ions. And that is why this area is called the depletion region. You can very clearly see in the figure. We have to know something about drift. You can see in the third diagram that the positive ions on the N side and the negative ions on the P side create an electric field. Just now we have seen. And due to this electric field, an electron from the p side, okay, there are electrons from the p side, as you can see in the figure, move to the n side. But this movement is because of the created electric field. Similarly, because of this electric field, a hole on the n side, I am talking of a hole on the n side of the junction moves to the p side. This motion of the charge carriers due to exclusively electric field is called as drift. And this drift current, the current which is generated because of this drift, it is called as a drift current. It is in complete opposition to the diffusion current. Diffusion means when PN junction are joined, because of the concentration gradient, there is diffusion of holes from p side to the n side and electrons from the n side to the p side. But what is drift? The motion of the charge carriers due to the electric charge or electric field created is called as the drift. Obviously, it is in opposition to the diffusion. And as clearly shown in the figure, the electron diffusion and the electron drift are in opposite direction. Likewise, the hole drift and the hole diffusion are in the opposite direction. Therefore, let us quickly understand the barrier potential. We have already seen what will happen if P and N type materials are joined. We have also seen what is meant by depletion region, right? And how electric field is created. Therefore, creation of the potential barrier, the separation of the fixed positive and negative charges establishes electric field, and the corresponding voltage drop across this field is called as the potential barrier potential, and this halts any further net charge, and equilibrium is reached. This barrier potential is generally zero point 0.6 to zero point 0.7 for silicon and 0.2 to 2.3 for germanium, which will be studying more when we are going to study PN diode. To summarize, we have seen what is the definition of semiconductor. It lies between insulator and conductor. What is meant by pure, that means intrinsic semiconductor. What is meant by extrinsic semiconductor? It is formed because of the doping, and doping is addition of impurities. We have also seen the energy bands. For insulator, the band gap is very large. For conductor, it is overlapping. But for semiconductor, the band gap is very, very less. We have also seen today how the PN junction is formed, what happens when P and N junction are joined. From next time, we'll be studying what is meant by diode, what will be the characteristics of diode, and what are the functions of the diode. If you want to learn more about semiconductors and electronics, please do join us at Goal Guru. Thank you.